Welcome. Today, I'll introduce you to the fabulous world of SBC through the use of Gitlab-ci, which we are using in the company I work for. Small is beautiful, as they say, but nowadays, small is powerful too. Is it powerful enough for our daily tasks? Let's see that together today. Of course, as its name implies, Gitlab-ci is the continuous integration part of GitLab. It's multi-platform because you can execute builds on Linux, Windows, macOS, and any other platform that supports Go. It's multi-language. Your build scripts are command-line driven and work with Java, PHP, Ruby, C, and any other language. It's stable. You have access to parallel build because GitLab CI/CD splits your builds across different machines. For fast execution, you have access to real-time logging. You have version test. You have pipelines because you can define multiple jobs per stage and you can trigger other builds. You have access to build artifacts, and of course you have Docker support, which means that you can use custom Docker images, build new Docker images, and even run on Kubernetes. Starting continuous integration with Gitlab-ci is really straightforward. Yes, it's that easy. You just have to create the Gitlab-ci YML file in your repository hosted in your GitLab instance, populate it with the commands needed to build your application, and you're good to go. But wait, where does that build and test execute? That's where the runners enter. Runners are machines linked to GitLab that will execute the builds. These can be real machines, virtual machines, or containers. GitLab and the runners communicate through an API, so the only requirement is that the runner's machine has network access to the GitLab server. A runner can be specific to a certain project or serve multiple projects in GitLab. If it serves all projects, it's called a shared runner. By default, you have access to shared runners on gitlab.com or even on your company's GitLab's instance. After installing the runner, you can either register it as shared or specific. You can only register a shared runner if you have admin access to the GitLab instance. The main difference between a shared and a specific runners are that shared runners are useful for jobs that have similar requirements between multiple projects. Rather than having multiple runners idling for many projects, you can have a single or small number of runners that handle multiple projects. This makes it easier to maintain and to update them. Shared runners process jobs using a fair usage queue, in contrast to specific runners that use a FIFO queue. This prevents cases where projects create hundreds of jobs, which can lead to eating all available shared runner resources. Specific runners are useful for jobs that have special requirements or for projects with a specific demand. If a job has certain requirements, you can set up a specific runner with this in mind. Why not having to do this for all runners? For example, if you want to deploy a certain project, you can set up a specific runner to have the right credentials for this. The usage of tags may be useful in this case. Group runners now are useful when you have multiple projects under one group and would like all projects to have access to a set of runners. Group runners process jobs using a FIFO queue. So to summarize, a runner that is specific only runs for the specified project, and a shared runner can run jobs for every project that has enabled the option Allow Shared Runners under Settings CI/CD. Projects with high demand of CI activity can also benefit from using specific runners. By having dedicated runners, you are guaranteed that the runner is not being held up by another's project jobs. You can set up a specific runner to be used by multiple projects. The difference with a shared runner is that you have to enable each project explicitly for the runner to be able to run its jobs. These runners are tagged so that you can also tag your builds accordingly. Tags are used to select specific runners from the list of all runners that are allowed to run this project. During the registration of the runner, you can specify the runner's tags, for example, Ruby, Postgres development. Tags allow you to run jobs with runners that have the specified tags assigned to them. This specification will make sure that the job will be built by a runner that has both Ruby and Postgres tags defined. Tags are also a great way to run different jobs on different platforms. For example, given an OS X runner with tag OS X and a Windows runner with tag Windows, the following jobs will run on respective platforms. Your builds can now easily be customized without ruining your own machine configuration and even use Docker. If you use Gitlab.com, you can use the shared runners provided by GitLab. These are special virtual machines that run on GitLab infrastructure and can build any x86 project. To enable the shared runners, you have to go to your project settings, CI/CD, and then click on Enable Shared Runners. It looks like we're all set. No need to go any further, Well, if you're using the main GitLab shared instance, chances are that you will have to be patient to get the results of your build. The shared runner concept is really cool as it allows to share the load, but you're not alone waiting in that queue. And the same could be true for your own company's instance, as it will soon become popular. So you could add your own machine to the GitLab runners herd just for your project. That's pretty neat if you're tired to wait for other people builds to finish, or if you have specific needs, want to feel like a DevOps engineer, or if you have too much time on your hands. The problem is, a new machine is not cheap. That's way cool to have your own GitLab runner running in your office, but have a quick look at your pocket's content. Do you have enough cash to buy a new machine? I don't, for sure. But wait, in the introduction, I was talking about ARM runners. Why would you need to add an ARM machine as a GitLab runner? The reason why I chose to install an ARM GitLab runner is clear. My own laptop is already busy with other tasks. And if your code does not depend on a specific family of processors, there is no other cheaper alternative than to build a new GitLab runner than to build it with an SBC. If it ever was able to run Docker and GitLab runner, 35 euros for a Raspberry Pi GitLab runner would be difficult to beat. And if you want to develop for that kind of architecture, ARMv7 or 64, you will need that kind of runner. I'm trying to port software to the ARM processor in the company I work for, and these ARM GitLab runners have proven to be really useful. I can develop on my favorite IDE on an x86 machine, for example, commit, and automatically my modified code will be compiled and tested on an ARM machine. I have to admit, all of this could also be done with x86 runners, as QEMU is able to emulate ARM processors. And even the build of ARM Docker images can be done on x86 GitLab runners thanks to the amazing work of folks at Resin.io, which is now Bolina. But where is the fun? And furthermore, we all have a Raspberry Pi taking layer after layer after layer of dust. So who has not been bored after having his first LED blink? Why not put it back to work? Let's go then for a cheap and fun solution. To perform the actual build, you need to install GitLab Runner, which is written in Go. It can run on any platform for which you can build Go binaries, including Linux, OS X, Windows, FreeBSD, and Docker. It can test any programming language, including .NET, Java, Python, C, PHP, and others. Let's see quickly how to install a runner under Linux. If you don't want to use a deb or RPM repository to install GitLab Runner, or your new Linux OS is not among the supported ones, you can install it manually. Simply download one of the binaries for your system, give it permissions to execute, create a Gitlab-ci user, install and run as a service. Note that these binaries now also exist for ARMv7 and ARMv8. Once the runner is up and running, you can then register it on your GitLab server. Go to your project on your GitLab instance, click on Settings, then on CI/CD, and click on Expand next to Runner Settings. Scroll down to set up a specific runner manually and note the information regarding the URL and the token. Run the following command. Enter your GitLab instance URL, enter the token you obtain to register the runner, enter the description for the runner, you can change it later on GitLab UI, enter the tags associated with the runners, you can also change this later on. Enter the runner executor. As you can see, you have lots of solutions to choose from, as GitLab Runner implements a number of executors that can be used to run your builds in different scenarios. We'll see later on that Docker may be not the easiest one, but the most adapted to our work, as it allows to have a clean build environment with easy dependency management. All dependencies for building the project could be put in that Docker image. The Docker executor also allows you to create a build environment with dependent services like MySQL. Now, check on GitLab that your runner is seen, and if that's the case, good job. Okay, let's do something funnier. Try to install GitLab Runner on the Raspberry Pi. It's readily available, cheap enough for my budget. Here comes the Raspberry. So a few minutes ago, I told you about using Docker for GitLab Runner because it's more practical. GitLab Runner has been ported to ARM in 2017 by Mauricio Igaz because it was not available, and everyone needs GitLab Runner on Docker running on ARM. So Docker exists on ARM, GitLab Runner too, and what about GitLab Runner in Docker? So ARMv7 and ARMv8 binaries are now supplied by GitLab, but what about a Docker image of a GitLab runner? Searching for the perfect solution for Docker on the Raspberry Pi, I discovered a distro called EpriotOS. The guys behind that distro call themselves the Docker Pirates. EpriotOS is a minimal Debian-based operating system that is optimized to run Docker. It makes it dead easy to use Docker on any Raspberry Pi by just downloading and flashing an SD card image. From start To finish, it takes less than 5 minutes to get started with Docker Compose, Docker Swarm, or even Docker Machine on the Raspberry Pi. How cool is that? There's also a 60-bit fork, as lots of Raspberry Pi distributions are not available for 64 bits. That's a nice plus. To me, that's the first choice if you want to use Docker on a Raspberry Pi out of the box. So first of all, let's download the latest Cypriot distro. You have to go to the Cypriot download page and choose the latest distro. Now, in the next step, we'll flash this file onto the SD card. We have to use Etcher to write correctly and check the written image on any platform. It's available for Windows, Linux, OS X. I do insist on the use of Etcher because lots of supposed Linux bugs on SBCs are because of a badly written image or to a faulty SD card. Etcher will take care of these issues. So if you're lucky enough to have an x86 Linux machine as a daily driver, you can also use Cypriot Flash Tool to write the content to the SD card. If possible, do not use any USB dongle or gizmo to host the SD card. Prefer your laptop or an SD card reader. And for the SD card, prefer real and genuine SD card. How can you differentiate a real one from a bad copy? Well, you can't. Or not easily. Anyway, write the image with Etcher to your SD card. And if you're lucky enough to have an HDMI screen and a keyboard, just log in thanks to Pirate Cypriot and issue an ifconfig command to find your IP. If you're not, or if you think there is no fun when it's too easy, after booting you can find the Raspberry Pi in your network with a simple ping blackpearl.local. No more searching for IP addresses required thanks to the integrated alleviate service discovery. You can then log into this IP or directly to Blackpearl. As you can see in the following ifconfig command, the MAC address of the Raspberry Pi always starts with B8. That could prove useful if ever the first method does not work. The default user pirate password Cypriot can be changed or removed before the first boot. Everything happens in user data. You can add your public SSH key, disable password login, and specify a different user account before booting your Raspberry Pi for the very first time. Wi-Fi can be customized and enabled to have Docker up and running through the air without ever attaching a keyboard nor a monitor. How cool is that? You just have to do the modifications before ejecting the SD card from your PC. You can also change the name of the machine later on with raspi config. The changes will have to be made in network options hostname. Once it's done, reboot and enjoy your new machine name. Check that the date on your machine is correct by issuing date in the terminal. If it's not correct, you will have some troubles getting a Docker image. So if the date time are not right, you can set them up with that command. Now, let's add our current user to the Docker group if ever he was not yet part of it. Most of the chores are done. Now that we have the right distro and Docker ready to roll, let's install the runner with Docker. As I said before, GitLab Runner has been ported to ARM in 2017 by Mauricio Yaz as it was not available. The image we'll use is built for ARM devices based on the official repo of the GitLab Runner. That's a fantastic work that made my daily work really more enjoyable. So you need to mount volume into the GitLab Runner container in order to share the configuration. Now this could be done this way. As we want to use Docker executor, it's necessary to mount the Docker socket this way. Unfortunately, with the latest versions of Docker, you may get this message. With the latest versions of Docker, TLS is enabled by default. So to use TLS, you will need to update the GitLab Runner configuration so that the certificates are shared between the service and the build container. So to do this, you have to update your config.toml so that it looks like that. The registration process is strictly the same than beforehand, except for the command, which will invoke Docker instead of directly invoking the GitLab Runner command. You could also do it directly this way. Use the same token than before and the same GitLab server address. You can change the description, of course, and the tags, as we should be proud of using an ARM machine. Once it's done, let's check if the new runner can now be seen. Refresh your CI/CD settings, expand runner settings, and go down. You should now be able to see a brand new Gitlab-ci runner proudly sporting its ARM tag. We now have an ARM machine sporting a recent kernel running a recent version of GitLab Runner on top of a recent version of Docker. We have reached the first level of achievement, having GitLab Runner running on the Pi thanks to Docker. Can we go any further? Could we build Docker images thanks to GitLab Runner on the Pi? If you're going to build images on this runner, you can use a standard Docker image as it's multi-arch now. Sometimes you may experience some troubles with the force when using Docker in Docker. So in order to address this issue, you need to look within the config folder you mounted in the runner container. There is a config file in which you need to add 2 lines regarding the privilege and the volumes, and then restart the runner with Docker restart ARM runner. If you can't find the file, it may be in your home directory, so edit it and then copy it in the folder you mounted in the runner container beforehand, and then restart Docker. So, it looks like we've reached a second level of achievement, being able to build Docker images thanks to GitLab Runner. We deserve now a good piece of cake, don't we? But it's not time to rest on our laurels. What about another challenge? Let's try it on another SBC, much cheaper with half the amount of memory. This time we'll change fruit, let's leave aside the Raspberry Pi and try with an orange. Do you think it could work? The Orange Pi Zero is one of my preferred SBCs and almost the cheapest to this date. You'll get it for about €9 and can run Docker with a very recent kernel thanks to the Ambient distro. So this distro is a fantastic community project which allows lots of SBCs to run recent Linux kernels with optimizations. Ambient is a lightweight Debian-based distribution specialized for ARM developing boards. It has powerful builds and software development tools and a vibrant community to boot. It supports lots of chips. If you go to the download section, you can see there are tons of different cards that can run Ambient. If you choose the Orange Pi Zero, you can see the specifications, and one of them is Docker, which means that you can run Docker on this board with Ambient. Yes, you can run Docker on a 512 megabyte ARM machine. You can even run GitLab Runner on Docker on it, and even Docker on GitLab Runner on Docker on it. So if you click on Docker, you will then be able to see the list of SBCs able to run Docker with Ambient. That's impressive. Docker does not come pre-installed with Ambient, so you have to install it like that. Not that you could get Docker pre-installed, as you can build this distro by yourself as long as you have a Ubuntu machine available. The rest of the commands to run the GitLab Runner are strictly the same as for the Raspberry Pi, so no need to repeat them. Let's just have a look at the result once the runner has been installed, registered, and started. Feel like taking a look? Here is a build of a Docker image on this very Orange Pi Zero I hold in my hand. Isn't it fantastic? We reach the third level of achievement. In the pitch and introduction, I was telling you about €15, but in the previous slides, I'm speaking of €9, so where's the catch? The fact is, a good 16GB SD card is only €6, so your runner would cost you €15. Add €1 for a micro USB to USB-A cable and you're good to go. With a smaller SD card, you could go for less money, or you could even get rid of the cable and use power over Ethernet. This card can be powered through Ethernet so that you could have your €15 GitLab Runner operate just about everywhere on the edge of the network as long as you have a PoE router. Some of the boards handled by Ambient or EpreOS are ARM64, also called Arch64 or ARMv8. So to tell you the truth, even the Raspberry Pi 3B is an Arch64. It's just that Raspbian does not handle it for compatibility reasons with their oldest board. So you can find 64-bit distros for the Raspberry Pi, like Arch Linux, Diode Pi, EpreOS. For other cards, Ambient does exist for ARM64, so does Docker. Until 10 months ago, we were kind of stuck, as GitLab Runner for Arch64 did not exist. The merge request had been running for almost 3 years until it got accepted. We are now able to use GitLab Runner on our 64-bit ARM machine and without using Mauricio Fork, just a standard Docker image directly supplied by GitLab. To sum up, we managed to set up a Gitlab-ci runner on a Raspberry Pi and then on the Orange Pi Zero. You now know how to transform your dusty Raspi into a GitLab runner, even able to build Docker images. In the company I work for, we have also installed it on other SBCs like the Odroid XU4, NanoPi Fire 3, and on the Thunder X2, just for fun. We are using them every day, as they are cheap, disposable, fun to use, and have a very small footprint so that we install them just about anywhere. I hope to have tickled your curiosity regarding these little beasts known as SBCs, and that some of you will join the peaceful ARM rebellion. Thanks a lot for your attention.